Hello dear students, I am Dr. D.C. Saxena, Professor and Head of the Department of Food Engineering and Technology at Sant Longowal Institute of Engineering and Technology, Longowal. I am here to present the paper Technology of Meat, Poultry, Fish and Seafood Products. Now in the present module, you will be knowing the different aspects of storage with respect to chilling and freezing of carcass and meat by my co-author Mrs. Aarti.
Hello students, welcome to EPG Pathshala. I am Khan Nadia from Sant Longwal Institute of Engineering and Technology on behalf of Ms. Aarti. Today I am going to talk about Module 10 of paper number 8, Technology of Meat, Poultry, Fish and Seafood. In this module, we will be learning about chilling and freezing of carcass and meat. To prevent or even to reduce the deterioration process, particularly microorganism development, chilling has to be carried out quickly after carcass dosing at the end of slaughter process, and the chilled state has to be maintained until the meat is processed for consumption. Chilling can be defined as the fundamental operation in applying cold to meat to reduce its temperature quickly. This is done in a cold chamber with intensive air draught or movement. Rapid cooling of the meat surface not only slows and nearly stops the development of surface microorganisms but also reduces weight loss and discoloration of the surface owing to hemoglobin oxidation. Different systems of primary chilling are in use, including immersion in iced water, especially for poultry, but air chilling is the most common. Freezing of carcass and meat. Freezing is usually limited to meat to be used as buffer stock, frequently intended for export or for storage with a view to later processing. When the preservation period is longer than that acceptable for chilled meat, freezing must be used to minimize any physical, biochemical, and microbiological changes affecting quality in storage. During freezing, most of the water content of meat, about 80%, solidifies into pure ice crystals, accompanied by a separation of dissolved solids. A product can be considered frozen when its center has a temperature of minus 120 degree or less. To reach this temperature, the product passes through the temperature range of maximum crystallization from minus 10 to minus 5 degrees Celsius. The speed of freezing is a very important factor as frozen meat quality depends mainly on the size of ice crystal formed. The lower the speed of freezing, the larger the size of crystals. In this module, we will be discussing about freezing of individual food, types of meat, chilling and aging, poultry and game birds, and also freezing. Freezing is an excellent way to preserve animal products such as meat, poultry, fish, and shellfish. In some instances, eggs and dairy foods can also be frozen for later use. Freezing does not sterilize food. The extreme cold simply retards the growth of microorganisms and slows down the chains that affect quality or cause spoilage in food. The quality and safety of the final product depends on how the product is handled before, during, and after freezing. Freezing affects the texture, color, juiciness, and flavor of foods. Freezing of individual foods. These directions should be followed for handling each individual food. First, for highest quality, foods need to be tightly sealed in moisture vapor resistant materials and then freezed quickly at 0 degree Fahrenheit or below. Don't freeze too much food at one time because the food will freeze slowly, resulting in a mushy final product. Add only the amount of unfrozen food that will freeze within 24 hours. This is usually 2 to 3 pounds of food per cubic foot of freezer space. If you have a large amount of food to freeze at one time, plan to have it frozen for you by a meat packaging plant or by another commercial freezer. Once the food is frozen, keep it solidly frozen at 0 degree Fahrenheit or below. Even slight fluctuations in temperature can cause the food to thaw slightly, resulting in a mushy product. Don't place unfrozen food on top of frozen food. It could cause the frozen food to thaw because animal products are very susceptible to growth of microorganisms that can cause foodborne illness. It's important to handle them carefully. Never leave animal products at room temperature for more than 2 hours. Also be sure to clean surfaces and utensils used for preparing the products for freezing. Packaging materials. Packaging materials used for freezing are: before preparing animal products for freezing, assemble the packaging materials you will use. The type of packaging material depends on the type of food being frozen. Personal preferences and the types of material readily available. The packaging material should be moisture vapor resistant, durable, and easy to seal, and should not become brittle at low temperatures. Special freezer paper is best for packaging meats, poultry, or fish. Heavy-duty aluminum foil or freezer wrap can be used, but they tear most easily. If enough air can be excluded, freezer bags or containers can also be used. When packaging meat, poultry, or fish for freezing, either the drugstore wrap or the butcher wrap can be used. The drugstore wrap is preferable except for irregular cuts of meat. These are best wrapped using the butcher wrap. Don't forget to label and date all frozen products. Meats: beef, veal, lamb, or pork. Select only high quality fresh meats to freeze. Cured meats such as ham and bacon can only be frozen for a short period of time, usually 1 to 3 months, because the salt in them hastens rancidity. Chilling and aging. Freshly slaughtered meat carcasses or primal cuts need to be cooled to below 40 degree Fahrenheit within 24 hours to prevent souring or spoiling. The meat should be chilled at 32 degree Fahrenheit to 36 degree Fahrenheit. Variety meats, liver, hard or sweetbreads are ready to be wrapped and frozen after they are cold. After 24 hours, pork, veal, and lamb are ready to cut, be wrapped, and frozen. Beef may be left at 32 degrees Fahrenheit to 36 degrees Fahrenheit temperature for a total of 5 to 7 days to age the meat, making it more tender and flavorful. Meat purchased from grocery stores is ready to be frozen as is or cut into serving size portions and frozen. Cutting of meat. Depending on individual preferences for the number of servings and cooking methods, the meat can be cut into roast, rolled roast, steaks, chops, stew meat, ground meat, etc. before freezing. Packaging. Package the meat in freezer paper or wrap using either the drugstore or butcher wrap. Freeze bags or containers can be used for ground beef, stew beef, or other meats frozen in small portions. Store-bought meat need to be overwrapped since their clear packaging is not moisture vapor resistant. If you purchase film wrapped meats from a meat packer, check to see if the wrap is a new heavy duty film. If so, it needs no overwrapping. Package the meat in meal-sized portions, removing as many bones as possible. Place 2 layers of freezer paper or wrap between slices or patties of meat so they are easier to separate when frozen. This will help speed thawing. Let us now talk about the different types of meat, which are large game and small games. Large game includes deer, moose, antelope, and others. Large game can be handled for freezing like any other meat or carcass. Trim and discard bloodshot meat before freezing. Package meat, seal, and freeze. Now, small game. Small game includes rabbit, squirrel, and other game. They should be skinned, dressed, and then chilled. Refrigerate for 24 to 36 hours until meat is no longer rich. Cut into serving size pieces or leave whole. Package, seal, and freeze. Poultry and game birds. Poultry and game birds should be of different quality. Select only high quality fresh poultry to freeze. The tender young bird is best for roasting, frying, and broiling. Choose the more flavorful older birds for braising or stewing. Package poultry in freezer paper or wrap using the drugstore or butcher wrap, or place in freezer bags. Store-bought poultry needs to be overwrapped before freezing because its clear wrap is not moisture vapor resistant. When packaging pieces, arrange them to form a compact square flat package so they will stack better in the freezer. After packaging, seal and freeze immediately. Quail, dove, duck, pheasant, and other game birds should be dressed and gutted as soon as possible after shooting. Cool and clean properly. Remove excess fat on wild ducks and geese since it becomes rancid very quickly. Freeze as directed for poultry. Do not stuff poultry or game birds before freezing them. During freezing or thawing times, bacteria that cause foodborne illness could easily grow in the stuffing. Commercially stuffed frozen poultry is prepared under special safety conditions that cannot be duplicated at home. Seafood. Fish for freezing should be as fresh as possible. Wash fish and remove scales by scraping fish gently from tail to head with the dull edge of a knife or spoon. Remove entrails after cutting entire length of belly from vent to head. Remove head by cutting above collarbone. Break backbone over edge of cutting board or table. Remove dorsal or large back fin by cutting flesh along each side and pulling fin out. Do not trim fins with shears or a knife because bones will be left at the base of the fin. Wash fish thoroughly in cold running water. Fish is now dressed or pan dressed depending on size. Large fish should be cut into steaks or fillets for easier cooking. Steaks and fillets. For preparation of steaks, cut fish crosswise into 3 by 4 inch thick steaks. For preparation of fillets, cut down back of fish from tail to head, then cut down to backbone just above collarbone. Turn knife flat and cut flesh along backbone to tail, allowing knife to run over rib bones. Lift off entire side of fish in one piece, freeing fillet at tail. Turn fish over and cut fillet from other side. Methods of freezing. To prepare glaze, mix 1 by 4 cup of lemon juice and 1 by 4 cups of water. Dissolve 1 packet of unflavored gelatin in half cup of lemon juice and water mixture. Heat the remaining 11 by 2 cups of liquid to boiling. Stir the dissolved gelatin mixture into the boiling liquid. Cool to room temperature. When cool, dip the cold fish into the lemon gelatin glaze and drain. Wrap the fish in moisture vapor resistant packaging, label and freeze. Ice glaze. Place unwrapped fish in the freezer to freeze. As soon as it's frozen, dip fish in near freezing ice water. Place fish again in the freezer a few minutes to harden the glaze. Take fish out and repeat the glazing until a uniform cover of ice is formed. Wrap the fish in moisture vapor resistant paper or place in freezer bags, label and freeze. Ice glaze. Place fish in a shallow metal, foil or plastic pan, cover with water and freeze. To prevent evaporation of the ice, wrap the container in freezer paper after it is frozen. Label and freeze. Freezing fish in a block of ice will produce a poorer quality product than using the glaze methods. Fish raw. Thoroughly wash and package in freezer containers or bags and boxes, leaving 1 by 4 inch head space. Seal and freeze. Seafood. Clams can be frozen either by in the shell or shucked. To freeze the clams in the shell, simply place the live clams in moisture vapor resistant bags. Press out excess air and freeze. To freeze the clam meat, shuck the clams, then clean and wash the meat thoroughly. Drain and pack in freezer containers, leaving 1/2 inch headspace. Seal, label and freeze. Crab. Select only live crab to prepare for freezing. Crab freezes better if not picked before freezing. Simply remove the back, legs, entrails and gills either before or after boiling the crab for 5 minutes. The claws and body or core of the crab that still contains the meat should then be wrapped or ice glazed and wrapped in freezer wrap or paper. Seal, label and freeze. Lobster. For best quality lobster should be frozen uncooked. Freeze the lobster whole or clean it and freeze just shell portions that contain the edible meat. Some lobsters have large front claws that contain edible meat, while others have edible meat mainly in the tail section. Freeze lobster in the shell to help keep the meat from drying out. Simply wrap the whole lobster or lobster portions in moisture vapor resistant wrapping and freeze. Lobster can be cooked and then frozen, but the quality will not be as good. Oysters and scallops. Oysters that are still in the shells should only be frozen live. A live oyster will keep its shell tightly closed or will close it when tapped. If you have the plenty of freezer space and want to freeze the oysters in the shells, simply wash the shells thoroughly and place in moisture vapor resistant bags. Scallops for freezing should be live until shucked. A live scallop will keep its shell tightly closed or will close it when tapped. To freeze, place shucked scallops in a freezer container, leaving 1/2 inch headspace, seal and freeze. Shrimps. Select high quality fresh shrimp for freezing. Shrimp can be frozen, cooked or raw, in or out of the shell. For maximum storage life and quality, freeze shrimp raw with heads removed but shells still on. Be sure to wash and drain the shrimp if frozen raw. Quickly chill shrimp cooked before freezing. Package in freezer containers or bags, leaving 1/4 inch headspace, seal and freeze. Chilling of meat. Red color is most stable at lower temperatures because the rate of oxidation of the pigment decreases. At low temperatures, the solubility of oxygen is greater and oxygen consuming reactions are slowed down. There is a greater penetration of oxygen into the meat and the meat is red than at higher temperatures. Changes in color have been reported resulting from chilling treatment. Taylor et al. 1995 found that electrical stimulation of pork produced higher lightness than paler values than those measured in no stimulated sites. Pre-chilling of pork has some effect on its color during the initial chilling period. After 4 hours of chilling, the musculature of sprayed ham becomes lighter and red and yellow values. Color change in chilling, freezing and storage of meat decreases. However, after 20 hours, there is no significant difference in the color values. The surface of the skin becomes lighter after spaging. Chilled storage. The muscle surface of fresh meat undergoes extensive oxygen penetration and oxygenation of myoglobin after short periods of exposure to air. The length of time meat is kept in chilled storage has an effect on the rate of color change during retail display. Feldhusen et al. Showed that there was clear color change after exposure in beef longissimus dorsi muscle stored for up to 5 days at 5 degrees Celsius. The degree of lightness, percentage of red and percentage of yellow all increased by 3 to 4 units. The color of meat stored for longer periods showed less intensive color change during 5 hours of exposure. Bacterial activity is another factor in pigment change in fresh meat. The primary role of bacteria in meat discoloration is the reduction of oxygen tension in surface tissue. Initial oxygen concentrations in packaging or approximately 0.15% will seriously compromise the color stability of both beef and lamb. Pork appears able to tolerate oxygen concentrations above 1% without obvious detrimental effect during short-term storage at chilled temperatures. Gill and Guinness have shown clearly that control of both storage temperature and oxygen content are required to stop color deterioration in controlled atmosphere storage of beef. Samples were packed in either nitrogen or carbon dioxide containing oxygen at concentrations between 100 and 1000 ppm. The color of samples of long Longissimus dorsi, which has a high color stability, had deteriorated after 4 hours at either 5 or 1 degree Celsius. Samples stored at minus 1.5 degrees Celsius with oxygen concentrations of about 400 ppm had not deteriorated after 48 hours. At 0 degrees Celsius, samples deteriorated after 24 hours at greater than 200 ppm and 48 hours at 100 ppm oxygen. Beef muscles with low color stability discolored under all conditions. Refrigeration of carcasses. Carcasses should go into the cooler as soon as possible and should be as dry as possible. The objective of refrigeration is to retard bacterial growth and extend the shelf life. Chilling meat post-mortem from 40 degrees Celsius down to 0 degrees Celsius and keeping it cold will give a shelf life of up to 3 weeks, provided high standards of hygiene were observed during slaughter and dressing. Carcasses must be placed in the cooler immediately after weighing. They must hang on rails and never touch the floor. After several hours, the outside of a carcass will feel cool to the touch. But the important temperature is that deep inside the carcass. This must be measured with a probe thermometer and used as a guide to the efficiency of the cooling. The rate of cooling at the deepest point will vary according to many factors, including efficiency of cooler, the load, carcass size, and fatness. As a general guide, a deep muscle temperature of 6 to 7 degrees Celsius should be achieved in 28 to 36 hours for beef, 12 to 16 hours for pigs, and 24 to 30 hours for sheep and goat carcasses. Failure to bring down the internal temperature quickly will result in rapid multiplication of bacteria deep in the meat, resulting in off odors and bone taint. High air speeds are needed for rapid cooling, but these will lead to increased weight losses due to evaporation unless the relative humidity is also high. However, if the air is near to saturation point, then condensation will occur on the carcass surface, favoring mold and bacterial growth. A compromise between the two problems seems to be an relative humidity of about 90% with an air speed of about 0.5 meter per second. Condensation will also occur if warm carcass are put in a cooler partially filled with cold carcasses. The cooler should not be overloaded beyond the maximum load specified by the manufacturer, and spaces should be left between carcasses for the cold air to circulate. Otherwise, cooling will be inefficient and the carcass surface will remain wet, favoring rapid bacterial growth. Once filled, a cooler should be closed and not be frequently opened to avoid sudden rises in temperature. When empty, the cooler should be thoroughly washed before refilling. Personnel handling carcasses during loading and unloading operations should follow the strict rules regarding their personal hygiene and clothing and should handle carcasses as little as possible. Freezing. The aim of freezing is to extend shelf life from weeks to several months. Bacterial growth stops at temperature below minus 12 degrees Celsius. Above that temperature, shelf life of meat is limited by the actions of its own enzymes, which cause fat to become rancid. The maximum shelf life at minus 18 degrees Celsius is 5 months for pork, 8 months for sheep and goat meat, 10 months for beef. Freezing is an excellent way to preserve animal products such as meat, poultry, fish, and shellfish. In some instances, eggs and dairy foods can also be frozen for later use. Freezing does not sterilize food. The extreme cold simply retards the growth of microorganisms and slows down the changes that affect quality or cause spoilage in food. The quality and safety of the final product depends on how the product is handled before, during, and after freezing. Freezing affects the texture, color, juiciness, and flavor of foods. Be sure to start with high quality food. Freezing does not improve food quality. So, students, let us now summarize what we have learned in this module. Meat itself is not a living organism, but it's subject to endogenic enzymatic activity or proteolysis, which causes muscle tissue to mature, become tender, and develop a typical taste. This process is retarded by cold. During chilling, air temperature must be in the region of 0 degrees Celsius with no decreased below -1 degree Celsius, which could freeze the meat surface and impair its appearance. Relative humidity during chilling operation should be kept fairly high to prevent excessive weight loss. The recommended rate is between 90 and 95%. Different systems of primary chilling are in use, including immersion in iced water, especially for poultry, but air chilling is the most common. Freezing is performed in tunnels or in chambers with intense air circulation called blast chambers. Air temperatures should be in the range of -30 to -35 degrees Celsius. Sometimes -40 degrees Celsius is used. Air is circulated at high speed from 2 to 4 meter per second and also up to 6 meter per second. An air circulation coefficient of 150 to 300 is used inside freezing chambers. Relative humidity is maintained at 95% or above. The main problem with frozen storage is deterioration in organoleptic quality. There may be changes in meat texture. Fat can become granular and crumble, and there can also be some discoloration of the meat. That's all about chilling and freezing of carcass and meat. Thank you.
Dear students, chilling and freezing of carcass and meat has been explained by my co-author, and now you know how important these processes are with respect to the shelf life of meat and carcass. Now in the next module, you will be knowing the processes known as curing and smoking, which are one of the basic preparatory procedures of meat. Thank you.